I'm going to work through the reaction of two pairs of aqueous ions. The first pair of aqueous ions is potassium carbonate, and the second pair of aqueous ions is hydrochloric acid. So potassium carbonate is the combination of potassium ion and carbonate ion. Carbonate is one of the common polyatomic ions that you need to have memorized. So we have K plus and we have CO3 2 minus. Hydrochloric acid is simply H plus and Cl minus. Because this is an acid, if you put it in water, it will produce H plus ions. So we've got our ions listed. Now we're going to make our neutral compounds that we'll start out with. So we'll cross the charges. So we have K2CO3. And since this is an aqueous ion pair that we're starting out with, it is, of course, AQ. And we're mixing this with HCl, which is also AQ. And then we're going to have our reaction. Now, as I've shown in previous examples, the way to determine what the products will be is that we will simply write the anion above where we're going to write the product. So our anion is going to be CO3 2 minus carbonate. And our cation, instead of being potassium, will now be the H plus ion. Our other new ion pair is going to be Cl minus. And instead of having hydrogen as its cation, it will now have potassium as its cation. The next step is to make our neutral compounds. So we're going to cross our charges. So we have a carbonate, which is a 2 minus, and H, which is a plus 1. So we will get H2CO3, and we will get KCl. Now what we want to do is we want to balance this reaction. If we start out with 2 potassium ions, we need to end up with 2 potassium ions. So we're going to put a 2 in front of the KCl. We start out with 1 carbonate ion. We end up with 1 carbonate ion. We start out with 1 H plus, and now we have 2 H pluses. So I'm going to put a 2 right here. And now for the last one, I have 2 Cl's because I have the 2 in front of HCl, and I have 2 KCl's. So we are now balanced. Any ion pair that has a plus 1 cation, so a group 1 cation, an alkali metal cation, is going to be an aqueous combination. That means KCl would be soluble in water. So we're going to put an AQ because this is a soluble ion pair. And then H2CO3, if you look at the bottom of the solubility chart that I gave you, H2CO3 does not exist. It very quickly decomposes into H2O, which is water in its liquid form, and CO2, which is a gas. And so your observation here would be that when mixing potassium carbonate with hydrochloric acid, you would end up seeing bubbles, and that would be the CO2 gas escaping.